everyone. Welcome back. We are going to be continuing and building on some of the knowledge that you have gained over the last few days or week or so about congruence, right? And actually even longer because you did this where we started with rigid transformations to prove congruence. We've really been at this. So our target or our objective for today, for this lesson, is to explore some more, ooh, that rhymes, triangle congruent criteria, right? So you have really figured out or learned about 4 different ways, or shortcuts, sometimes I like to call them, because who doesn't like a shortcut, to prove triangles congruent. And those were side, side, side. And when I'm saying triangles, 2. A pair of triangles. You need 2, not just 1, 2. Side, side, side. Side, angle, side. Angle, side, angle. And angle, angle, side, right? So what these were saying is, I'm going to call them triangle congruent. You know what? I'll use the symbols. This is a great time. Congruence criteria. So if you have 2 triangles and all corresponding sides of those 2 triangles, remember corresponding means that it's in the same place, same location on a different triangle. You have 3 pairs of corresponding angles that are, sides that are congruent. Those triangles are congruent. If you have 2 corresponding sides that are congruent and the included angle that is congruent, then the triangles are congruent, right? And then we got into angle, angle, side, and angle, side, angle, which we saw some overlap because remember, if you know 2 angles, you realistically know the third, which we'll talk about more today. So angle, side, angle was 2 corresponding angles are congruent. And the side between them, the side that overlaps that they both have. And then you have angle, angle, side, which is 2 angles. And then the side, which is it's like the swing side. It's the side that's not, it's only attached to one of the angles. Those both prove congruence as well. So these were enough to prove congruence. We didn't need to know every little part. So we're going to look into 2 more ideas that we haven't explored yet. So we're going to explore side, side angle and angle, angle, right? And maybe you're wondering, that's weird. Why does she only have 2 angles? Well, we'll talk about that if you're not sure yet. To see if to determine if they are sufficient criteria, is this enough to prove 2 triangles congruent? Like, do we need more or is this enough? So that's what we're going to be looking into. So you guys actually have a capture sheet that goes along with this, and that is what we expect that you are completing. So hopefully you have it out in front of you while we are working through this. And if not, this would be a really good place to, pause the video and get it or at least pull it up so that you are able to write stuff down as you're watching the video and get that done. Amazing. Let's get started. So let's first explore side, side angle and what we're later going to refer to as hypotenuse leg. So I'm going to take you to this website, GeoGebra. This is actually linked on the capture sheet, so if you want to explore these or any of the other ones over here, that would be a great idea. So I just want to reiterate. I'm going to go over here and grab some nice color. So I've got 2 sides that aren't going to change. So this side down here, that was really bad, and this side down here. And I'm not looking at the included angle. Remember, it's side, side angle. So I'm going to focus in on this 40-degree angle. So these are the 3 things that I know. 1, 2, 3. So we don't want to change the length of this right here, right? But I'm going to drag it a little bit. And I'm going to see, oh, look. Right, I haven't changed the length. It's still 10. There we go. Got a triangle. Got a triangle. Is there any other triangle that I can create? Or what if I keep swinging it? Whoa. That makes another triangle. Right? So I have the same exact criteria. I still have 14, 10, and 40. Angle, side, side, or side, side angles. Angle. 2 sides and a non-included angle. But I get option 1. I get option 2. Those aren't congruent. Those are certainly not the same. Here I get an 116 and 24 degree angle. And here I get 64 and 75. Not the same. Huh. Let's change this around a little. What if I make this side shorter? I'm going to make it like that. And I'm going to drag it. Oh no. It literally can't even make a triangle. This is bad news, guys. I can't even make a triangle with this. Well, what if I... Let's see, what could I do? What if I made this longer? Let's say I want this one to be a little shorter. I'm going to change this around. Let's go with this. So I'm going to drag, can I? Yeah. I'm going to drag this. Look, I get one triangle. Okay, let's try that swingy thing again. I mean, I get another triangle over here, but that's not even with this criteria. That's not even with my 40-degree angle. I just lost my 40-degree angle when I did that. So that creates one triangle. Huh. I wonder, so clearly it doesn't work, right? Like, it works sometimes I got no triangles. Sometimes I got 2 triangles. Sometimes I got 1 triangle, right? So when this was 12, this was 11, and then I had the angle, it worked. If I make this 9, I've got 2. So 9, 11, and then the angle doesn't work. And when I make it like really little, it doesn't even create 1. Huh, that's pretty, I don't know, maybe we'll refer to it as ambiguous. This is actually called the ambiguous case, and it is something that you will learn later on. So what we're getting at here is if we take 2 triangles, if we know 2 triangles have corresponding and congruent side-side angle, is that enough to guarantee congruence? No. We just looked at it, right? It could have 2 triangles, no triangles at all, or 1 triangle. So like it might be congruent, but we really don't have enough information, right? So if we have side-side angle and that is the information we're given, it is really not enough info. Like, we don't know enough. We need more. They need to tell us more. They might be congruent. They might not be congruent, but like, we just don't know enough. Right, so let's look at some of these examples that were given here. So draw the triangles below to determine which of these guarantees that the triangles are congruent. So I'm going to actually go ahead and just draw, I'm just going to sketch some triangles. And I'll call this, not drawn to scale, ABC. And I'll call this, why would I call it ABC? That would be ridiculous. The other one is DEF. So let's mark it off what we're told. Angle A and D are congruent. A and D. And are they corresponding? Yes, they are. B and E, those correspond, are congruent. So I've got 2 angles, and then AB, that's the side between them, and DE, side between them. So are these congruent? Yes, by angle, side angle. 2 angles and the side between them. If you understand what I'm asking you to do, maybe pause the video and try these next 3. So I'm going to do the same general sketch, and I've got A, B, C. I'm going to orient them the same way because it's simpler for me to look at. Angle A, let's grab a color, is congruent to angle D. AB is congruent to DE. And then BC is congruent to EF. So I've got 2 sides and the angle that's not between them. Whoop! Isn't that side-side angle? Isn't that what we just talked about? So are these triangles congruent? Not enough info. Right? SSA, think about what that spells the other way. We're not going to write that. Does not prove congruence. I'm going to go that route. What about this? What is it? A, B, C, DEF. Oh, we just got some angles here. A and D, B and E, C and F. Whoa, we just got 3 angles? I don't think we know anything about this yet. You know what? Let's just put some question marks. Like say, hey, we're going to explore that in a little bit, but right now I'm going to say not enough info. I haven't learned enough to answer this question. Right, so knowing what you know already, like you can only use what you know. And then let's take a look at this last one. A, B, C, and D, E, F. A is congruent to D, AB is congruent to DE, and AC is congruent to DF. That's a silly looking F. What about these? 2 sides with the angle between them, right? It's the angle where those 2 sides meet, right? They share that vertex. So yes, by side, angle, side. All right, so here and here, we didn't have quite enough information. This one we just explored a little bit, right? Like we would need to know more. We would maybe need to know those lengths to figure that out. Whereas here, we just haven't even looked at that at all. Right, so really what we can conclude, and I wonder if I can get myself back to this page. Will it let me get back to that? It won't. My goodness. It really doesn't want me to show it to you guys. Why not? My goodness. I can't get back to it. Okay. Well, one of the ones that we looked at was if I think that bottom side was like 14, right? That was 14. Didn't matter what that was. And then when this side was like 12, I was able to get a triangle here, and then it swung around and created another one over here, right? So kind of like when you had 12 and 12 here. Right, so when I had a shorter side and then the longer side and then the angle, I got 2 triangles. If you remember, if I had one that was like way too short, right, so there's my angle, there's my 14, and there's my little one, let's say like 5, I got no triangles. So that was an issue when I had the shorter side and then the longer side and then the angle. Like that really didn't work for me. When we had it the other way, and I actually rearranged it a little bit, and I believe I made this 11 and this one 12, that created one triangle, right? Because when I swung it around, it ended up over here, which didn't have that 40-degree angle anymore. So when I had long side, short side, and then the angle, it worked, right? So I'm going to indicate that as like I'm going to kind of narrow my thought process here. We can conclude that when SSA works, it is long side, short side angle. So I'm going to say big S, little SA. That's a little silly, right? Like, you think we're going to make you write that? You're probably like, yeah, I do. This means long side, right? And this is like knowing numbers. Short side. I don't know why I'm writing the word side again. I guess I don't need it. All right, long, short, and then the angle, right? So the angle is attached to the shorter side. The one that's swinging is my longer side. But we don't often know how long the sides are, right? They're usually marked off like this. So it has nothing to do with like, then I want to indicate this, the number of marks does not, you could add this to your notes, indicate how long a side is. Like it doesn't. Just because this has 2 marks does not mean that it is my long side. It doesn't, right? So like let's not assume that. So, but does this fit? Like, I'm looking at it and I'm assuming that AB and DE are longer than this other side that's marked off. But, like, is that true? Is there a word you could use to refer to AB? Maybe you can really think back. I wonder if anyone is like, oh my gosh, I know this. It's the hypotenuse. Right? Because we're looking at oh, check this out, a right angle. And if you look across the right angle, that is our hypotenuse. Right? So AB is a hypotenuse, as is ED. And the definition of the hypotenuse is it's the longest side. Like, it is by definition the longest side of a right triangle. So I've got this right triangle. I know this is my longest side. This one's got to be shorter than it. So if I go around this triangle, this is my long side, this is my short side, and then this is my angle. This is my long side, this is my short side, this is my angle, right? I have two right angles. So I have long side, short side, angle. So in fact, these two triangles are congruent. This does meet this criteria. And here is an example of, without knowing numbers, how we can figure that out. Because it's not super common that you're going to be given numbers, right? We're usually given things that are marked off. We're not usually given lengths and measures, lengths of sides and measures of angles. So what we can conclude is typically, as I just said, we will not know the actual side lengths and angle measurements. If we are given a right triangle, we know the relationship between the sides, right? That has to do with the hypotenuse. Is the longest, right? And you guys have, if you don't have room for notes right there, there's a place for notes at the bottom, like on the end of this. So the hypotenuse is the longest. It's across from the right angle. I'm using some symbols here. That's just an exclamation point. We do not say that the triangles are congruent by SSA. That is not what we're telling you to write. So we do not say this. Instead, we know the hypotenuse, and the other two sides are called the leg. So we say HL, which stands for hypotenuse leg. This is the special case of SSA, right? So now we've added a fifth way to prove triangles congruent, and it is HL. It only works for a right triangle. You will never be writing SSA or the other way around, right? If you get something and you're like, well, this is long side, short side angle, for the purposes at least of this course, you will be saying HL, right? We're not going to be giving you examples that have numbers on them. I'm going to be honest about that. So that won't be something. You will deal with that when you get to different levels of courses. Like, you deal with this. It's referred to as the ambiguous case in pre-calculus, right? Which many of you guys will take that course in 2 years. So this will come up again. So I do want to emphasize that just because you have a right triangle does not mean that HL is how they are congruent. For instance, let's say I've got these two triangles. I'll call it SMP and JOB. It's a right triangle. I'll say this, and I'll say this. Okay, so I've got angle P is congruent to angle J, angle S and angle B, because they're both right angles. That's the definition of a right angle. All right angles are congruent. And MP and OJ. Right? So I see a right angle. I'm probably tempted to just write that they're congruent by HL. Nope. Don't do it. I've got two angles, two corresponding angles that are congruent, and a side. And you know where that side is? It's not between them, right? So you can even like mark it off. Angle, angle. and the sides outside of them, so angle, angle, side, right? So I can prove these congruent. I can say triangle SMP is congruent to triangle, what does S correspond to? B, M, BOJ by angle, angle, side congruence, right? So just because it has a right angle does not mean that it is HF. You might need to star that and write that to yourself. Let's explore that other one, right? Like we saw this come up a little bit. This angle, angle. So you guys have a link to this as well. Oh, look, now it's back. I don't know why it wouldn't let me look at it before. I'm not going to do too much with this, but just check this out. What's happening? You see them markings? So angle A, this one right here, is the same mark as P. They correspond and they're congruent. C and R, they correspond and they're congruent. B and Q, they correspond and they're congruent. Remember, corresponding and congruent are not the same thing. That's why I keep saying the word, right? That's why I'm saying both of them. They don't just mean the exact same thing. So let's see. As I move this, I can probably get them to be congruent, but I'm like moving it around and those angles are staying the same, but I'm like evidently not looking at the same triangle. Right? So just knowing that you have 3 angles that are congruent, like, is that enough to prove congruence? I don't know. Right? I can even flip it. And I still, no, I don't know. I don't think it is. What do you guys think? What if I asked you to draw a triangle that had approximately 40 degrees and 70 degrees? Go ahead and pause the video and do that on your paper. I'm going to do it too. I'm going to approximate it. Let's say that's about 40. And I'll say that's about 70. I don't think that's about that at all. I'm just really approximating now. Is my triangle the exact same one that's on your triangle? Do you think that's what's on your friend's triangle? Do you think that's what's on Miss Warren or Mr. Wong or Miss Lovelace's triangle? Like, I don't think we all have the same triangle, right? Like, I could have been like, oh, there's mine. There's 40 and there's 70. 40 and 70, and mine's tiny, right? So will all triangles with angle measures 40 and 70 be the same? No. What does that mean? Just knowing 2 angles of one triangle are congruent to 2 angles of a second triangle does not mean the triangles are, let's use a symbol here, congruent. It doesn't. This is not enough information, right? Like, I don't know how big or small it is. I need a side to figure that out. If I knew these 2 angles and a side, I might be able to figure something out. But I don't, right? I don't even care what side. Any side will do. But before we even really go quite that far, like, it doesn't prove congruence. It's not enough information. It doesn't disprove congruence. I would need more information to disprove it also, but it doesn't prove it. Like, it is not a shortcut. It's not going to get me to where I want. It's not one of our favorite shortcuts. So the 3 interior angles of a triangle, what do they add up to? Like, why was it okay that I only gave you 2? Like, why am I not giving you 3? They all sum to 180 degrees. No matter how big or small the triangle is, no matter how teeny tiny or massive it is going to sum to 180 degrees. And this is known, and some of you guys probably have said this before or heard this, this is known as the triangle sum theorem. It's come up throughout other things, and this was one of the ways that we showed that angle, angle, side works, right? Because it links to angle, side, angle, right? There's a close link, and it's basically like, as long as I know 2 angles in any of the sides, I'm good to go because I know the 3rd angle. So even though I only gave you 2 angles here, we can figure out this 3rd angle. right? If I did 40 plus 70, that gives me, what is that, 110. And then 180 minus 110, I know that that last one is going to be 70 degrees too. Oh, it's isosceles. How cool. So not all isosceles triangles are congruent. There you go. Pretty cool statement. Not all equilateral triangles are congruent. Right? I could have a little equilateral triangle with 3 congruent sides, then a big equilateral triangle with 3 congruent sides. But they're not congruent to each other. It's like it's blown up. It's like when you zoom in and zoom out. Think about a square. Just because I say square, we're not all going to have the same square. But yet all the angles are 90 degrees. Knowing the angles doesn't help me do anything. So what we can conclude, and I know maybe we kind of concluded this, but to formally conclude it, knowing that 2 pairs of corresponding doesn't equal congruent. I'm going to write that again, really big. They're not the same thing. Just because, like, you can have things that correspond, right? But they are not congruent to each other. Like, I can put something in a corresponding location, but that doesn't mean it's exactly the same. So knowing that 2 pairs of corresponding angles are congruent does not, make sure you have that whole thing in there, I didn't give you a lot of room, prove congruence. Important note, this does not mean that the triangles are not congruent. It just means that there is not enough info to prove congruence. And this is the same thing with HL as well. That rhymed as well. Oh. We're not necessarily disproving congruence. We're just not proving congruence. We're basically saying, I need more. I need to investigate this further to be able to draw a conclusion about it. So what we learned in this and what we now know is that we have 5 shortcuts is what I'm going to call them, because as I started with, who doesn't like a good shortcut? 5 shortcuts to prove congruence. And what are they? Maybe you can pause the video and you can write them down and be like, do I know them all? In order too. We had side, 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 angle, side, angle, side, angle, and angle, angle, side. That's what you came into this video knowing. And now you also know HL. Right? And remember, HL only works for a right triangle. But again, just because you have a right triangle doesn't mean you go right to using HL. Investigate. Don't assume, like really analyze what you have and investigate it. And those are our 5. And so if you are trying to prove congruence, let's say you didn't have a multiple choice question. Every single question can be a multiple choice question. You can look for, is it one of these 5? Okay, it's not. That is not enough info. There might be cases where it's straight up not congruent, right? And we might have enough information to say it's not congruent. But for the most part, and for the intent and purposes of what we're doing, you are looking to prove congruence, not disprove congruence. So you're going to go with that not enough information. So what we did in this video was we explored through some of these applets, which you guys have access to if you want to play around with them more and get a better understanding of side, side, angle, and angle, angle to determine if they are sufficient criteria. And what we did determine was that side, side, angle only works for big side, little side angle, like in that order. And realistically, all we'll be using it for is HL. And angle, angle, which we talked about how that is, I didn't need the third angle because we can figure it out from triangle sum theorem. And that is not enough information because it doesn't tell us how large that triangle needs to be. So make sure that you have completed this capture sheet that goes along with it. And if you have questions, there's a place at the bottom that maybe you can write down your thoughts now and bring them to class that we can talk about all of these things when we see you there. Thanks, everyone.